This is chapter 4.1, exercises 25 through 36. Section 4.1 of the book has to do with angles. In this case, angles in radians and degrees and the arc length, finding out the arc length or using the arc length to find a radius or the angle. And to do this, we're going to use the arc length formula. And it says use the appropriate arc length formula. There are different versions of it. We're just going to use one of those. And the arc length formula is this one. It's simply S equals R theta. And S is our arc length. R is our radius. And the units of the arc length and radius will be the same usually. If not, then they can be converted. And this theta, and I'm going to write this out, it's a Greek letter. It has to do with angle measure. So theta, it's the angle measure. And one other thing that's really necessary to understand is the units of this angle measure are not degrees. The units are another unit called radians. And a measure of an angle of a radian, a single radian, is the distance of one radius. So we're going to kind of explore that. Anyway, I'm going to put the formula here. S equals R theta. In this case, we're trying to solve for S. So S, our arc length, is our radius, which is 2 inches, times 25 radians. So S is going to be equal to 50 inches. And what this physically looks like, if you have a circle, like I'm now sketching in black, and that circle has a radius of 2 inches, a arc length of 50 is going to be several rotations around this circle. So that's practically what it's going to look like. So here's our answer. Arc length 50 inches. Next, problem 27. Now this time we have R that is our unknown. We're trying to solve for R. But we're going to use the same formula. S equals R theta. But in this case, we're trying to solve for R. So to solve for R, we're going to have to divide both sides of this formula by theta. And when we do that, we cancel theta over theta on the right side. So we're left with R equals S over theta. And what that means for us is R equals S, which is 1.5, and theta is pi over 4, and our units are radians. It says RAD. And what we have is dividing by a fraction the same as multiplying by its reciprocal. So instead of dividing by 1.5 by power 4, we can multiply by 4 over pi. And what we have here is 4 times 1.5 is 6. So we have 6 over pi, and our units are feet. And that's approximately equal to something I did earlier in my calculator. 6 over pi is approximately equal to 1.91 feet. 1.91 feet. So that will be our answer for problem number 27. Next, problem 29. Similar situation. We're trying to find theta. We don't know what theta is, but we know what S and R are. So if we have S equals R theta, how do we solve for theta? Well, we solve for theta by dividing by R, the radius. So we have theta is equal to S over R, which is going to be our arc length, which is 3, so we have 3 divided by 1, which equals 3, and there'll be units will be radians, which I'll abbreviate RAD. And what that looks like is that if we have a circle, like I've drawn earlier, and that circle has a radius of 1 meter, 3 radians is going to be what I'm now describing in red, approximately. And on the outside in red, that's going to be your 3 meters. Now, how did I know the right distance to draw? Well, the reason I knew the right distance to draw is that pi radians is equal to 180 degrees. And so 3 being a little short of pi is the same as being a little short of 180 degrees. And so I hope you get involved in this long enough to get kind of an intuitive sense of that. Next problem, 31. This time we don't have the R. We got another situation. This theta is in degrees. And you remember from the arc length formula we looked at earlier, we had to be in radians. So we're going to need to convert this 20 degrees into radians. Well, to do that, it kind of builds upon what I was sketching the last time around when we had that 3 meter arc length. If you have a circle here, and you start at 0 on the far right and cycle around counterclockwise, halfway around the circle is 180 degrees, which is the same as pi radians. And so we have this identity, 180 degrees equals pi radians. So we can go and kind of use that to solve. So let's go ahead and do this. We have S equals R theta, and if we divide by theta, we're going to need to divide by theta to solve for R. So dividing by theta, we have R is equal to S over theta. Now, this 20 degrees, let's convert that to radians. So we have 20 degrees, and to convert that 20 degrees into radians, we're going to multiply by pi radians over 180 degrees. And from dimensional analysis, you need to multiply so that things are canceled. So degrees over degrees cancel. So what we're left with is 20 over 180, which is 1/9. So that's going to be 1/9 of pi, or pi over 9. And that's going to be in radians. So now we take R is equal to S, which is 40, over pi over 9, which is our angle, and that's going to be equal to 40 times 9 over pi. Dividing by a fraction, same as multiplying by its reciprocal, and 40 times 9 is 360. So we have 360 over pi, and that's going to be in centimeters, which is going to be approximately equal to, I think I calculated that earlier, 114.6 centimeters, approximately. So that's going to be our answer to problem number 31. Problem 33. Now this is a different little set. We got central angle, exercise 33 and 34. Central angle theta intercepts arcs S sub 1 and S sub 2 on two concentric circles with radii R sub 1 and R sub 2 respectively. Find the missing information. What I'm going to draw now is two concentric circles. I'll draw this first one here, which is my inside circle, and then our outside circle. Okay, not such a great drawing, but it'll just have to work for us. And our inside radius is 11 centimeters. So here's our 11 centimeters. And our outer one, R sub 2, is 44. Well, that's going to be significantly larger. So to get a better sense of proportionality, I'm going to make this second outside circle much larger so more accurately represent a proportional radius. And so I'm going to make this, let's see, 44 is 4 times as big as 11. So I'm just going to make this thing way bigger. I know I'm not going to be able to draw a thing 4 times bigger exactly, but so I'm making at least twice as big. Okay. Okay, that's not so pretty, but we'll just okay, something like that. So, another thing. Okay, so we'll call this a green one. We'll call this 44. And we have S1, which is our arc length. I'm going to draw in red, is going to be 9. So I draw this little arc length of 9. Then what is going to be our, if we have a central angle that I'm now sketching out here in black, intercepts arcs S1 and S2. So here's S1, and up here is S sub 2. And this one here, this arc is going to be way up here. We're trying to find our S sub 2, which is this one right here. So we're going to get a direct proportionality. So we're going to have S sub 1 is to R sub 1 as S sub 2 is to R sub 2. And to fill in the equation here, we're going to have S sub 1 is 9, and R sub 1 is 11. And on the other side, we don't know what S sub 2 is, but we know it's divided by R sub 2, which is 44. So if we cross multiply the 44, so X is equal to cross multiplying this 44 over here, we have 9 times 44 over 11. And 44 over 11 is 4, so we have 9 times 4, which equals 36. And that's going to be in centimeters. And then it finally says, find the missing information. Well, to find theta, we haven't, I'm going to create a little room here. I'm going to erase part of this circle to leave some room to figure that out. Again, we have the arc length formula, S equals R theta. And if we want to find out what theta is, we just need to divide by R. So theta is equal to S over R, and we can use either one of these. S is going to be, we can take 9 over 11. So theta equals 9 over 11, and it's going to be radians. Okay, so that's going to be that one. We found that out. We found x, that's going to be S sub 2 is equal to 36 centimeters. So there we have our information. So a little bit of a puzzle to find these out. Take a look at problem 34, a similar type of problem using kilometers. Next, our last one we're going to look at, to the nearest inch, find the perimeter of a 10-degree sector cut from a circular disc of radius 11 inches. Well, just to draw what that looks like, we got this circular disc here, and we mark in the center. We go over here. This will be 11 inches. And we want to find a 10-degree, find the perimeter of a 10-degree sector. So 10 degrees is going to be just a very small slice. I'm trying to draw a little 10 degrees, something like I just drew there. And we're trying to find the perimeter of this, and the perimeter is going to be what I'm now sketching in red. The entire outside of this slice. So it's like a pie slice or a pizza slice. That's what it is. And so our perimeter is going to be equal to the distance around. So we're going to take this 11 and this 11. So we have 11 plus 11 plus this arc length here. Well, the arc length, we have a 10-degree swath. So we have that equation earlier, S equals R theta, to find that distance. Well, S is going to be equal to R. We already know R is 11, but theta, okay, theta equals 10 degrees. And 10 degrees, if we convert that to radians, which we're going to need to do use this formula, we got to multiply by pi radians over 180 degrees. And so degrees over degrees cancel each other. And so 10 divided by 180 is 1/18. So we have pi over 18 radians. And so we're going to just multiply this S by theta. So that's what this theta is right here. Pi over 18, which is 10 degrees. So we multiply by pi over 18. So going to our calculator, we have S, which is 11, times pi, and we're going to divide this by 18. I think that should get it for us. We have, yeah, we got about 1.92. So let's go back here. 1.92. It's going to be inches. And so here our perimeter is P is 11 plus 11 plus 11, 11 plus 11 plus 1.92. That's going to be inches. And we can just kind of, we have 11 plus 11, that's 22, plus 1.92. So our perimeter is going to be equal to approximately 23.9 or 92 inches. So that's going to be this video lesson. Take a look at the even number problems for enhanced practice and understanding. Good luck, as always, and thanks for viewing.